Hi there and welcome back to the channel. I'm the GCSE science teacher, and in today's lesson we'll be learning about elastic potential energy. This is for GCSE physics. Let's get started. So, what actually is elastic potential energy? Well, it's the energy that's stored in objects which can be stretched or squashed. Often we're talking about springs, and this links into the Hooke's law experiment, which is a required practical in the physics GCSE course. So, the equation that you need to be aware of, and you are given this in the exam, is as follows. So, elastic potential energy, or EE, is equal to a half times K, the spring constant, times extension squared. And the spring constant is just a measure of how stiff or elastic that particular spring is. And this will vary. Depending really on what the spring is made of and what the metal and the material actually is able to do. One other thing to mention is the units of these different quantities. So the energy, or the elastic potential energy, is always going to be measured in joules because it's an energy. The spring constant is going to be measured in newtons per meter. And you can see that because there's newtons there, it must be something to do with force. And that force, when it's applied to a spring, can actually cause that extension. So the extension is a measurement of length, and we give it the units meters. So extension, just as a bit of extra knowledge to know, when I have taught this in the past and I've marked work on this in the past, a lot of students actually understand what I mean by extension. Extension is the length that has been increased after the initial length of the spring. And it's important to be aware of that because sometimes they can give you the initial length and the final length, and you need to then calculate the extension by working out the difference between the two measurements there. An example then that we should be aware of, let's have a go. Calculate the elastic potential energy of a trampoline when the extension of the spring is zero point 0.3 meters and the spring constant is 15 newtons per meter. So first thing you want to do in the exam, if you get a question like this, is highlight the key bits of information and write out the equation that you need. You then want to put the numbers into the correct space so it's underneath each other. You can see 15 is the spring constant K and zero point 0.3 is the extension. Also, be aware when you're writing this out in your calculator, you can always just use zero point 0.5 instead of using the fraction button on your calculator if that's easier. And definitely don't forget to use brackets when you're putting in your square function for the zero point 0.3, because sometimes calculators, depending on the variety you're using, it can actually misread it. So you may want to also put brackets around zero point 0.3 or the extension number when you are squaring your answer there. Once you've popped that in, you can see you get an answer of 0.675 joules, or you can just round that up to zero point 0.7 joules and underline it. Don't forget the units as well. So here's an example that you can do yourself. Calculate the elastic potential energy found within a toy which has springs with an extension of 0.12 meters and a spring constant of 23 newtons per meter. Comment your answer down below. Don't forget to show your working out units, etc. And we'll see how you get on. Lastly, but not at all least, is the ability to rearrange the equation. You may be expected to do this if you need to work out the extension or the spring constant K. And you can see that K is equal to the elastic potential energy divided by zero point 0.5 times the extension squared. And if you want to work out the extension, you need to square root your equation. So square root is 2 times the elastic potential energy divided by the spring constant. Often students misplace or forget about the square and square root being the opposite of each other. So sometimes we can use the triangle method to rearrange equations, but just be aware not to rely on that method all together, because actually sometimes if you've got more complicated equations, it's harder to work out how to do this manually. So if you would like more help and support with rearranging equations that are a bit more complicated, feel free to comment down below and I'm more than happy to do that. But in the meantime, if you want any more GCSE content for physics or indeed for biology and chemistry, please do check out my channel. I have more videos on there. And you can also find other GCSE content on my Instagram at the GCSE Science Teacher. But in the meantime, thank you so much for your time and watching the video. I've been the GCSE Science Teacher and you have been curious. Don't forget to like, comment, and subscribe, and I'll see you in the next one. Bye.